One of the comments that I always get in these flat earth videos that I'll upload, typically the ones I'll do about the movements of the celestial bodies or gravity, one of the responses I always get from these globe believers, the more triggered ones, is you don't understand physics. And my response is always pretty much the same. I'm like, oh, look, another physics expert. Well, here, how about this, genius? Go ahead and explain the physics of liquids or water in large quantities. Now, do they ever do it? No. For some reason or another, globe believers like to tiptoe around that particular aspect of physics. So let's do a quick check on understanding, a real simple rudimentary exercise, and then we're going to look at physics real quick. How about that? Now, what do you see here? A globe. B, a bowling ball. C, a spherical balloon. A globe. Moving on. Now, what is the most prevalent surface color on this globe? A, white. B, green. Or C, blue? Blue. Very good. What does the blue on the globe represent? A, land masses. B, water. C, lava. B, water. You would be correct if you guessed B. Under what state of matter is water classified? A, a solid. B, gas. Or C, a liquid? And if you chose C, you are correct. Now, let's take a look at the conclusion here. Most of the Earth's surface is covered by liquid. That's what we just established by answering those questions. Still with me? Good. Now, let's take a quick look at a short video outlining the physics of liquid.
Liquids seek their own level. Let us perform an activity to show that liquids seek their own level. Take a series of interconnected tubes of different shapes as shown here. Pour colored liquid into one of the tubes. Observe that the liquid stands at the same horizontal level in each tube, even though the area of cross-section of each tube is different. We know that the pressure at the top of each tube is equal to the atmospheric pressure. Similarly, the pressure at the bottom of each tube will also be equal. Hence, liquids seek their own level.
Okay, so to go along with that, here's an example. Here's a cross-section side profile of the Panama Canal. Now, what you can see is on the far right side, it shows the Pacific Ocean at sea level, which you can see is pretty much flat on the surface. And then what happens is the boats move across Panama through a series of locks, rising and lowering the level of the water, moving across the landmass, and then coming out to the other side on the Atlantic Ocean, which is also at sea level. Now, this side profile here shows that, in correlation to what we just saw as the physics of water, that the surface of water is always flat. That water, liquids, seek to find their own level. Now, you in your own personal experience have never seen water do anything on the surface other than represent a level surface, as if a perfect mirror. Now, if the surface of water were bulging, such an effect wouldn't be possible. This whole mirror thing that we have going on right here, that's not possible if the surface is curving. But then this is where people would make excuses saying that this particular body of water is too small and that there's not enough space to see the curvature. So let's take into consideration what you're seeing here. This is the world's biggest mirror. It's the salt flats in Uyuni, Bolivia. This place is 100 miles across and about 80 miles wide. And after it rains, there's about inch or two of water and it becomes a perfect mirror, as you can see here. That doesn't happen on a globe. That's entirely too much missing curvature. So you know the physics of water. Water seeks to find its level, and that's what the surface of level water looks like, right there. Perfect mirror. Accumulates and gives off that reflection, indicating that there is no curvature on the surface. This is one of my originals from a while back, and this is just to get you thinking about this stuff, the simplicity of where we are. Whether it's water in a glass, whether it's in a pond, a puddle, in a lake, or on the ocean, the surface is always flat and level. You need to take into consideration the fact that bodies of water only appear to curve in pictures that you will never be able to take for yourself. And that's the pictures of the entire globe. Chances are you're never going to go to space and be able to snap that picture. Neither am I. But what we know in our reality is that the surface of water is always level. So I'll admit it that both of these models have their own flaws. But you gotta ask yourself, which one of these matches your experience in reality? What's closer to what you know? Water clinging to the outside exterior of a ball, or water finding its level? That's all I got for this one. As always, be good to each other, take care of yourself, and stay flat. I'll see you next time. Thank you.